So now I'll just talk about backend of this app that I've made. And so you just put the job description and it ranks the resume. So here's how it works. It's the phase one, which is the text extraction layer. And then you have phase two, pre-processing and chunking. And then you have the section classification. So let's just drop into the code. So this is my text extraction layer, which is using FIDS, which is PyMu PDF, and it just extracts the text and it returns it. So that's my first function. And I've made this whole project, and all this is it's just job description. I used to test on these uh, in this file. I don't know why. I just do it. But the main thing is it returns the full text, and this is our function first, and it extracts the text. So this is our now second function, and what it does is it takes the extracted text of this resume and it just divides it into chunks. And you're doing this by splitting on this basis of this. So it's a splits at every new line, full stop, semicolon, asterisk, and all that. And then you just take the important words like MLAI, NLP, and all these. And except these words, we just remove all the other unnecessary short words because text extraction always has some sort of noise, and so it's random ease spamming somewhere or something like that. So we just take this valid chunks, and if not in these, we just remove everything else. So just the output of this is just letters and numbers, and then you just take the consist project section. What this is doing, that in every chunk, if the resume is talking about, if the chunk is talking about project, which would have verbs like built, developed, worked, and programs, improved, and all these, then it's going to keep those chunk in like, then it's going to like extend that chunk. So we can just say that the first chunk is talking about any of these build developed. So over here, we just take this and we just find, okay, so it's inside the verb is present in the chunk. So we just merge it into a temporary buffer. And then on the next chunk, we just see that does the next chunk also contain something about created or anything in the verb. So we just merge it again into the buffer. And if it's not in the next chunk, suppose it's not, we just append that buffer into our merge chunks. So basically we have this one line that was split into commas. So I built ML model, and I trained and I fine-tune it using Optuna, or let's just say tune it using Optuna. So that's talking about the project. So we wouldn't want that to be split into two parts. We just want that together as one line. So for better semantic understanding of our model. So that's why we're just doing that, and that's what this whole thing is all about. And then you just have this section classifier, which is the brain of everything. That's why this is different and this is better than my version 1. And it is because that I have all these stuff. I'll go into this later. Let's just go into the code so that I could explain. So we have these, basically we have this domain, and this domain is our this domain anchors, and we have like front end, we have all this skills experience project of front end, we have backend, we have skills experience project of backend, and same with the ML. And what we are doing is we're just figuring out that our job description is talking about what. Is it talking about ML? Is it talking about backend? Is it talking about front end? So it detects using the cosine similarity. And I'm not going to each and every line of the code. That will be too long. So basically, in short, it just detects using cosine similarity, converting that into embeddings. And once it figures out that, okay, job description is talking about machine learning, so we are just going to use this skills anchor, experience anchor, project anchor, and we append that into a more general anchor. So the problem this solves is if the job description is talking about front end, so we can have front end anchors detected, and we can append that. So it's flexible in each and every case. And then you go down there, and I'll show you the purpose of appending that. So now we go here and we have this chunk and chunk embedding, and we are just creating the resume text into the embeddings using this model and code. We did the same with the job description earlier. I didn't sell it, so that's the chunk embedding. And what we are doing is we are comparing the cosine similarity of each and every chunk. So as I said, we divide a resume into chunks. So we are comparing each and every chunk with those anchors. So you can see that's the base anchor. So these base anchors have appended these domain anchors. So these are much more fine-tuned for our resume, for our job description, my bad. And then we are comparing the cosine similarity. And based on cosine similarity, we just check that if this current chunk, it's talking about skills or it's talking about experience, education, project, or whatever. And we do that by just computing the scores, taking the max score, and we'll say if the max score is about skills, then that chunk should be appended to that skill section. And by the way, I don't know if I showed you the sections. So these are the sections. So if the chunk is talking about skills, we append that to our skill section. And that's what all this is doing. And at the very end, we have our sections returned. So that's our function. It takes chunk list and job description text. And then these are helping functions, nothing too deep about them. And this is our another main function. It's about comparing job description with the resume. So what we are doing is we are taking all these sections and we are converting those sections into embeddings. And then we are taking, so we have to basically, the idea is to compare these sections with the embeddings of job description. So we are also comparing, computing the sections of job description. So as you can see in the job description, I add these two things: JD skill focus, JD experience focus. So in the embedding of my skill embedding, so I could have created like 4 embeddings, but I decided to do it with 2 because it's very hard to extract like things to compare with job description, because it's not as it's not structured the way a resume is. So I'm just taking 2 of them. One is skill anchor and one is experience anchor. So in my job description skill embedding, I am just taking the whole job description text with this anchor. So now I know that this embedding is for checking with the skills, against the skills to be more precise. And then this is our experience, and we do it to check job description against the experience of our resume. And then to as obviously I'll have to repeat these because I only have 2 of them. So we are comparing skills with skills and experience with experience, project with experience again. So that's repeat, education with skills again. And now I don't know, it's not that good logic. My code is not meant to be perfect, but it's decent. It's decent. Less work and it's kind of decent because skills is similar-ish to education. So that's why. And then you just have all this stuff. We are just doing the weighted average. So these embedding scores, these are the scores, and we're doing the weighted average. So we are just taking the weight, divided it by total, and then we multiply that with the weights. We multiply the final score of all these with the weight. So we just want that skill to have more percentage, so it's going to have more weight multiplied to it, and weights to have less percentage than skills, then it's going to have less weight. So this is the weighted average, because that's how job recruiters think. They want that the skills to have the maximum weight, and maybe then experience, and maybe the project to have maximum weight. So you can tune that. It's pretty tunable over here. And then this is my function. So because these are too many functions, right? I'm not going to call all these functions. So I just created one forward pass function. My bad if I spelled it miscorrectly. So forward pass function is just taking the resume text and the job description text, and that's it. And it does all of this for you, and it gives you the final score. So when I'm working in the front end, all I have to do is I just have to call this forward pass function, pass it the resume text value, the job description text value, and so it's going to give me the final value to rank it. And it is that simple. And on this website, as you can see that I have all the same thing. So this is the final score for this resume. This is the final score for all this, and you just rank it based on a simple logic. So the highest score is going to be at the first, and the lowest score is going to be at the last. And as you can see, this job description is about natural language processing. So let's just see the highest ranking resume has natural language processing or not. So I just open this and I just see the resume one, and you can see this, it's filled. I don't know, I just found this resume randomly LinkedIn somewhere. So it has all this stuff, and it's pretty natural language processing vibe to me. And it's got all this terms, and yeah, so it's pretty good for the job description. So that's why it ranked it the highest. And then you have this resume 6. Open the resume 6. And yeah, so it's also talking about reinforcement learning, AI, NLP, GPT. And then you have this, and then you have my own resume, and it's also meant to be NLP and machine learning. So that's why it's also been ranked higher, as you can see. And these are the projects. And the lowest is our lawyer. So, lawyer, and this resume 7 example. So as you can see, it's lawyer. So these are the most irrelevant resumes. So that's why they've gotten such a small score. So this model is not perfect, but it gets the job done.